Alright guys, so today we're gonna we're gonna be going over the concept of using Newton's second law to calculate the change in center of mass velocity when an external force is exerted on a system. So our question or example today is a box of 20 kilograms and a box of 5 kilograms, each of uniform density, are on a horizontal surface connected together with a string and pulled to the right by a different string connected to the 5 kilogram box with a force of 20 newtons for 3 seconds. The strings have negligible mass, and the friction between the boxes and the horizontal surface is negligible as well. So calculate the final velocity of the system if it was initially moving to the right at 5 meters per second. So using what this question says, we come up with this type of illustration. And so we know that Newton's second law, as stated, is the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Written as a formula, that means that acceleration is equal to F net, or the force divided by mass, and we normally say that as force is equal to mass times acceleration. So here is a fresh illustration of what the question asked for. We see that this whole system is made up of two boxes of uniform density. The left one is 20 kilograms and the right one is 5 kilograms. So the string is pulling this whole system to the right with a force of 20 newtons, and we consider this whole thing to be the system. The mass of the strings are negligible, as well as the friction when the two boxes are being pushed to the right, or pulled to the right. So the first thing we want to do is figure out the center of mass. Now, we know that the center of mass, as previously stated, is the average position of all parts of a system weighted according to mass. So the formula that we can use to figure out the center of mass is this. So x, which we delineate as the position, is equal to the mass of the first object times its position plus the mass of the second object times its position over the total masses. In this case, we can say that this is mass 1 and the 20 kilogram box is mass 2. So now if we do the total math, we get 5 times 1 plus 20 times negative 2 all over 5 plus 20 is equivalent to 5 minus 40 over 25, which is equivalent to negative 35 over 25, which divided further, simplified further, is equivalent to negative 7 over 5, which is negative 1.4. So we know that the center of mass is negative 1.4 in the x direction. As we see that the center of mass in this case, they're both the same in the y direction, in the y-axis, and as the whole system is being pulled in the same part in the y-axis. The only thing that's changing when we look at the center of masses is the x-axis, and therefore that's the number we get. So negative 1.4 is approximately right over here, and thus we see that this whole system acts as if it were just a single dot at a single point at this point. And so the total gravity would be slightly greater, the force, as we're considering this whole system to be 25 kilograms now. This would be the force of gravity, and that would be the normal force counteracting the force of gravity. So although they're not the same thing, they produce the same result. This whole system contained these two boxes and the strings of negligible mass act as if the whole system were to be a single a dot at this point, weighing 25 kilograms, of course, with the force actually pushing that point to the right. And so these are just equivalencies. So we have so far that the force is equal to 20 newtons. We know that the initial velocity is equivalent to 5 meters per second. And we want to find the change in velocity in order to find the final velocity, as change in velocity is equal to Vf minus initial velocity, and that is a question mark. So in order to find the final velocity, we have to find the change in velocity. So how do we do that? Well, we use a formula that we got from Newton's second law. F equals ma. This is the most important formula that we need to use for this problem. Alright, so we know that the force is 20 newtons. We know that the total mass is 25, as it's 5 kilograms plus 20 kilograms, multiplied by the acceleration. Therefore, we get that the acceleration is equal to 20 over 25, or, simplify further, 4 over 5, or 0.8 meters per second squared. Now that is the acceleration. And we know that acceleration is equal to change in velocity over change in time, delta v over delta t. Now that means that delta v, if we just simply use some simple algebra, is equivalent to acceleration times delta t, which in this case would be 0.8 times 3, as the force was acting on the system for 3 seconds. So we get that delta v, which is equal to velocity final minus velocity initial, is equal to 2.4. If we use some simple algebra once again, or some substitution as well, we get the velocity final minus 5, which was, velocity final is equal to 5 plus 2.4, as we simply add vi in both sides. And we know that vi is equal to 5 meters per second. We get a total of 7.4 meters per second. So the center of mass velocity is therefore 7.4 meters per second, and that means that while this whole system was moving to the right at 5 meters per second initially, which is equivalent to this single point being pushed with the force 20 newtons to the right, and it's going at 5 meters per second, is now going at 7.4 meters per second after 3 seconds of being pushed with the force of 20 newtons. So I hope you enjoyed the video. I hope you learned something new, and I guess we'll see you in the next video.